Welcome, everyone. Today we are going to talk about covariational reasoning, which is a physics sense-making strategy that is most concerned with thinking about how two different quantities are changing together, which is why we call it covariation, because we're thinking about how things are co-varying, changing together. Whenever we're doing any sense-making, we're going to follow our general outline, which is to choose a sense-making strategy, in this case, covariational reasoning. We're going to think first about what should the strategy say, giving physical reasons, and then check what our answer or equation actually says, and then see if those two things agree with each other. I'm going to demonstrate this by thinking about the definition for average acceleration, which is the change in velocity divided by the change in time. So first of all, I want to think about what my situation should be. So I know here that I have three quantities: average acceleration, change in velocity, and change in time. And I want to leverage my personal, physical, everyday understanding. So I could think about examples of changing velocity and accelerating, like driving a car, riding a bike, running on the street, things like that. And in all of those situations, if I have a small change in velocity, I tend to feel small accelerations, where if I have a big change in velocity, then I tend to feel big accelerations. Thinking about the difference between, say, slamming on the brakes to go from 20 miles an hour to 0 miles per hour versus putting on the brakes to go from 5 miles an hour to 0 miles an hour. Bigger change in velocity tends to give me a bigger acceleration if the time is equal. On the flip side, if I have the same change in velocity, I want to go from 20 to 0, but the time is different, slamming on the brakes versus coasting to a stop, then I know from sort of what I feel in the car or on a bike that the acceleration is going to be a lot bigger for the case where the time is a lot smaller. Then I can go and look at the equation, and what I see is that delta V is in the numerator, while delta T is in the denominator. And this lets me do some equation-based proportional reasoning to think about the fact that a bigger delta V, because it's in the numerator, means a bigger average acceleration, whereas a bigger delta T in the denominator gets divided and gives me a smaller acceleration. And this is exactly in alignment with what we predicted from our physical reasoning and our everyday understanding.